Because what's the difference between a sine wave and a cosine wave? There's 0, right? And there's 2 pi. From there to there is a perfect cycle of a cosine wave, right? So what would be the most obvious way I would want to write the equation of this? What's the amplitude? From here to here is what? Okay, cosine starts at 1, 0, negative 1, 0, 1. If you like digital, feel free to memorize that. Sine's different, right? Sine is 0, 1, 0, negative 1, 0. I don't know, that might be helpful, it might not. But the picture is the important part. The period still, we're not there yet, is 2 pi. That doesn't change, okay? I'm talking about x here. Is there a phase shift with cosine? No. Is it up or down? No, it's right at 0, right? So if you like, put a 0 there, but kind of redundant. And I don't need the 1. That's just our good old cosine x. But what's another way I can describe this thing? Could I call it a sine wave? Where does a sine wave start? At 0. So is that exactly one period of a sine wave? It is. The amplitude is still 1, but how far is it away from 0 here? That's pi over 2, isn't it? That distance. So if this thing shifted left by pi over 2, isn't that the same thing? Sine wave is a cosine wave. The wordage is out of phase by 90 degrees. Is pi over 2 90 degrees? Okay? So this is called a phase shift, not a horizontal translation. Okay? New wordage. Everyone agree? Is that the same thing? Don't need the 1 there. I could put a plus 0 too. It's not up or down, right? But that's another way I could describe this. What else? Is this a cosine here from there to there? Shifted over by 2 pi? Yeah. I mean, it repeats every 2 pi. So I could do that endlessly, right? But it's kind of cheating. I want different ways to describe it. I could go minus 2 pi. That would be the same thing too. Okay? What else? What's this? So that's a minus a sine x. And how far away from this 0 is that? That's pi over 2 to the right. So there's another way I could call this wave, right? Oh, yeah. Okay? Yeah, only one x there. Any others? Oh, there's infinitely many, but we're not going to do them. I've got a sine, I got a negative sine. How about a negative cosine? What can I do to make that a negative cosine. Negative cosine would start here, wouldn't it? Okay, so that would just be negative cosine, and what's my phase shift here from there to there? X minus pi or x plus pi? It doesn't matter, right? Because that's the same thing. Okay, there's lots of choices. That's one I didn't give you yesterday. Okay, they're all equivalent. They're all exactly the same thing. Do you think you could put that in your calculator and put all of those in there and you'll get only one graph? You should. And if you get more than one graph, well, I guess you made a mistake. There is a way to check it. Okay? Okay. 73. Let's put the whole thing together. Before, we called this a vertical expansion or compression. Now we're calling it an amplitude. Okay? Amplitude. You know that from science. How big is the wave? You did that in Science 8. This is called the phase shift. Okay? The horizontal left or right thing. This was a vertical up or down. We're calling that a vertical displacement. Kind of makes sense. So the only one we haven't done was, can you see that? Yeah. The period change. Everything so far has been right up to 2 pi for a period. But what happens if you take that wave and you compress it? Okay, this is what we had before. If I compress that wave a lot, maybe I get something like that. Okay? If I expand it horizontally, well, then you know what's going to happen. It gets longer. So we're going to change that a bit. Okay? So that's what I kind of said there. The process. And again, you can try to do that first chapter method if you want, but like I'm not going to teach it like that. We want to do vertical displacement kind of first and amplitude at the same time. Otherwise, we might get like 4 different graphs, and I know not all of you are as neat as like a carrot here, okay? You won't be able to read your own work. So try to do a couple things at the same time. Period change is what you want to do next, and then finally draw that and then phase shift it. You can clearly see those 2 graphs, okay? Maybe 3 max. But if you got like 5 in there, it's going to be pretty tough to see it. So, where do we start? Right there. Okay, plus 1. This is 1, 2, 3. There's 1, 2, 3, 4, 5. That's going to be the center of this wave. It's up by 1. It's not at 0. It's up by 1. Okay? Next thing I want to do. It's a sine. It would normally start there, but it's up 1. It still starts there. How high does it go? It goes up to 3. Okay, but where is that going to be? Well, this is where this comes into play. The period change. I know it goes up 3, so let's actually go 1, 2, 3. Goes up to there. And 1, 2, 3, it goes down to there. All right, this thing's in between this band. That's its highest point, maximum, and that's its lowest point, the minimum. What does that 2 do? That was a vertical expansion by 3, kind of like this one. What did that do when it was bigger than 1? Yeah, horizontal compression by 2. Okay, so that's one way to think about it. If I compress this thing by 2, the period used to be 2 pi. If I compress that by a half, what's a half of 2 pi? And I think I said horizontal compression by 2. It's a half, right? It's always inverted. Half as big as it was. It's squished. So my new period is a pi. So there's 2 pi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. That's where pi is. That's where this thing ends up. It starts at 1 here, but 0 on this scale. That's where it ends up, right back there. Okay, sine normally looks like that. Halfway in between, I know it's also got a 0 there, right? So 0, 1, 0, -1, 0. Halfway in between, 1, 2, 3, it's also at a 0. Halfway in between there is where its maximum is. I've already got the line there, so I don't even have to count. Where's halfway in between here and here? Right there. Where's halfway in between these two? That's where the minimum is. And that's there. So you can draw that, which I will. But that's not my final answer. I still got one more thing to do, right? I've done that, I've done that, I've done that. Lastly, what does that mean? Pi over 6 to the right. How much is each one of these? Yeah, so we're going to be kind of nice, all right? Each one of these is pi over 6. Isn't that convenient? So my final graph, let's do black. That's to the right, it's negative, so it's going to go there. It's going to go there, that's going to go there, that's going to go there, and that's going to go there. And it repeats, okay? It doesn't just stop there, let's just put little arrows in. That's just one period of it. Okay? What's the amplitude? It's 3. That's that number there. It's up by 3 or it's down by 3 from the center position. Vertical displacement, up 1. Phase shift, pi over 6, right. The new period is half of what it typically is, normally. What's the max? Well, now we can count. 1, 2, 3, well, that's 4. Feel free to use that funky formula if you want. Okay? What's the minimum? That was 0, -2. So the formulas say things like 4 minus -2 divided by 2 is the amplitude. Is it helpful? I don't think so. Draw the picture and look, okay? But if you want to memorize them, feel free. Okay? That's it, guys. I couldn't ask you a harder question, okay? That's all we're doing. Do you guys have the brackets in your book? Okay, yeah, I don't either. Put them in there. Yeah, okay? 2 sets of brackets there. You don't need this bracket per se, but it's there. And I know in the other chapter, sometimes you had it, sometimes you didn't. Okay? It's just a visual thing. All right? Scale is important. Most of these, we're going to give you the appropriate scale. It's going to work. Whatever that is, that's what you want one of these squares to be. But in some questions, maybe you got to build your own. Maybe it'll just be a blank grid. You want to do something that's going to work. Plus, how the heck am I going to mark it if it's something really weird, like something like Dannon would do? Right? Let's make it, I don't know, 236 pi, each one of these. That's 1/18. Okay, you know, yeah. Okay, let's do another. What do you want to do first? I want to do that first. That's the center of this thing. It will go up to and down to from there, because that's the amplitude. Amplitude is always positive, okay? I know it's a negative. We got to flip it. Let's just put that in there too. Up 1, okay? So this thing is going to go up to there, and it's going to go down to there. Almost made a mistake. Okay? Upper and lower limits of this wave, which happens to be a cosine wave. What's next? Okay, I've done that, I've done that. I still got this to do, I got that to do, and I got that to do. Yeah, I can reflect it, but what point am I going to reflect it from first? Cosine wave usually starts at 1, right? Ends up at 1, goes down to -1. Halfway is the minimum, the maximum is where it starts and where it ends, which usually is 2 pi. Okay? Are we being nice? What was I just saying? I want each square to maybe be pi over 3, maybe pi over 6, because they're divisible by one another. This is pi over 3, right? So you could start here. Each one of these is pi over 3. That's 2 pi over 3, 3 pi over 3. Every 3 of these is a pi. That's 2 pi. 3 pi, 4 pi. What is my period? Yeah, the inverse of 1/2 is 2. Horizontal expansion by 2. It's usually 2 pi, so this is 4 pi, and oh, wouldn't you know it, we go to 4 pi. Okay, so let's draw that. Then lastly, I'm going to draw another one and phase shift it. I would normally start at 1, but the amplitude is 2, but this negative is going to flip it over. Now you might want to draw that one first and then flip it, but I think I'm kind of confident I can just flip this thing first. So it's gonna start there and end up right back where I started, right? At my new period of 4 pi. You okay with that? What's halfway between 0 and 4 pi? That's where my maximum is, because it's going to be flipped. Halfway between the min and the max are my 0 points, there and there. So that's 1, 2, 3, 4, 5, 6 at 1, 2, 3. But my 0 point, when I say 0, I mean this center line. Okay? So this guy looks like that, nice and round, no points. That's what I graphed. Got one more thing to do. What does that do? That is going to go left pi over 3. So this is pi over 3. So that point will go there, that one there, that one there, that one there, and that one there. Okay? So I've only got 2 there, and it almost looks confusing. Can you imagine if you had 4? If I drew a graph for everything I do, okay, good luck, even if you have 4 colors, right? Period is 4 pi, okay? It's horizontally expanded, double what it was. Max, 1, 2, 3. The minimum is -1. There's, I don't know, 4 marks, maybe 5. Okay? No graphing. What's the amplitude? 7. What's the vertical displacement? Down 4. What's the phase shift? Pi over 6. It's negative, so it's right. What's the period? Okay, this one's kind of tricky. Is that less than or greater than 1? Which means what? By a factor of 3 over 2. What's 3 over 2 times 2 pi? 3 pi. Yeah, you could. Now this I don't have a picture of, so it's kind of tricky, but think. Okay, it starts at -4. Well, I mean, sorry, that's my center line. My amplitude is 7. So what's -4 and 7? Yeah. And then -4 down 7 from that would be, okay, piece of cake. Seven up 2. Pi over 2 right. What's my period? Is that bigger than 1? Yeah. So that is a, well, if we got this one right, then we know this one, right? Horizontal compression by 2/9. All right, Smarty, what's 2/9 of 2 pi? Exactly. Okay. It's ugly, but I'm answering the question. I would never give you that to graph. Well, don't quote me. Maximum. I'm going to start it at 2. My amplitude is 7 positive. I don't care if I'm flipping it, right? Yeah, 9. And if I go down 7 from 2, it's, okay, it's from there to there. It doesn't really matter if it's positive sine wave or negative sine wave. This doesn't change. Okay? This is one you want to know. The period is 2 pi over b. So let's look at this question. What's b again? Like it's this thing, the horizontal compression or expansion thing. When I say b, that's what we mean. So here, b is 2/3. So let's look at this formula. The period is always 2 pi over b. What's that? If I times that top and bottom by 3 over 2, that's gone. And that is 6 pi over 2, which is the same thing as what we got before. Okay? And I put that in my calculator, but it'll make it a decimal, right? So it's not even that helpful. Okay? So that we can use, or you can just do it the way we just did it. It's a different way of thinking about it, but I know when you get to university, that's how you're going to want to think about it. Okay, last one. Ready? A sinusoidal function has a maximum at pi over 8 and 12. That's wonderful. That's a plot point. Where do I plot it? Do you think we would be that nice to you? I'm not sure of that. Maybe each one is a pi over a 4. Or a pi over a 16, and that's 2 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got to divide 2 pi by 16 lines, which is, oh darn it. So pi over 8, each one of these is a pi over 8, right? So if I'm going to plot that, this looks like it goes up by 1, so that's kind of nice. So pi over 8, 12, that's 15, 14, 13, 12. That's a maximum. That's good, because I don't have much graphing above it. The next minimum is there. I probably want that in terms of eighths, so I can plot it. What is 3/4 in terms of eighths? Yeah, that's the same thing, right? So I'm going to 1, 2, 3, 4, 5, that's 6/8 pi, and -4. Okay, I got 2 dots. What's the equation? And here's where it gets to be a problem, because there's an infinitely many solutions, but it says use cosine, that's what we're going to use. Because maximum is where cosine starts, remember? Okay, it starts there, it ends up there, usually at 2 pi. This is the max, this is the minimum, which is usually at pi. Where's this one at? 6/8 pi. So how do I find where my next maximum is going to be? From here to here is how many pi? That's 5/8, isn't it? So if I go another 5/8 pi, okay, where's that? 7, 8, 9, 10, 11/8 pi. Is the next max.
I thought you said there's a maximum of 2 pi.
This is a different period. That's not a 2 pi period. Otherwise, this min would be right at a pi, right? Okay, so I want to use cosine, and it looks like a positive cosine. Okay, what is my period? Here's a formula for finding what b is, or finding what period is, or whatever I don't know, which is there's only 2 variables here. This is what I can use to find out what b is. What's my period here? From there to there is what? From 1/8 pi to 11/8 pi is 10/8 pi. That's my period, right? So I'm solving this thing for b. Pi's cancel out. What is 2 over 10/8? That's 2 times 8/10, which is 16/10, which is 8/5. It's ugly, but that's what it is. Now let's actually put this over here. Okay, this is a plus. What's my amplitude? I don't know yet. Okay, but this is an x minus 8/5. Yes. I'm a little rusty with this stuff. That's my excuse. Okay, this is my phase shift. Thank you. All right, that's my maximum. That's my minimum. Halfway in between is going to be my vertical displacement. Okay, this is -4. This is 12. What's halfway in between those? That's 16. Half of that is 8. If I take 8 from here, I'm right there. Right? So let's get that next. That's my vertical displacement. It's up by 4. What goes here? Amplitude. What's my amplitude? From here to here is 8. It's the same here, right? Okay. Only got one more thing to do. It starts here, right? It gets to 0 somewhere halfway in between here and here. 1, 2, 3, 4, 5. So 2.5. It's a minimum there, and then 2.5 later is a 0. Back up to there if I want to draw my pretty picture. But the only thing I need is just this. How far is that? That's my phase shift. Do I want a plus or a minus? This thing's moved right, so what's that? So it's pretty nasty. If I put that in my calculator, hopefully it makes that picture. Hey, that's it, guys. I think tomorrow we'll do more of the same. Sound good? Or does everyone get this like no problem and we can just move on?
I would like to do that.
Oh.